Okay, and so today we are going to look at logarithmic functions and how to graph them. Okay, so from our example here that 2 to the power of 3 is equal to 8, and where we know that log 8 to base 2 is equal to 3, we can see the relationship between logs and exponents. Okay, and so that's going to be the same with our functions for log functions. When we're graphing them, we will see that they're also, there's a relationship between those, between log functions and exponential functions when they're graphed. Okay, so here in this question we're asked to graph the following function, which is f of x equal to log x to base 4, and x is an element of the reals and is between 0 and less than or equal to greater than 0 and less than or equal to 64. Okay, so before we do up our input box for x, because obviously we're not going to go and have an input box of x values 1, 2, 3, 4, 5, 6 all the way up to 64. So really all the time when we are graphing log functions, we will always use the powers of the base, always. So here our base here is 4, so our input values for x will be 0, 4, 16, and so on, 16, 64. Okay, so just make sure to write this rule into your copy, it's very important. Okay, so now we have our input values done. So 4 to the power of 0 is 1, 4 to the power of 1 is 4, 4 to the power of 2 is 16, and 4 to the power of 3 is 64. Sub them in and we get, well, log 1 to base 4 is 0, log 4 to base 4 is 1, log 16 to base 4 is 2, and log 64 to base 4 is 3. And so we can plot our graph now, which is this graph here, and we can see our points on it, and it is sloping upwards, and we can see the steepnesses early on, but in the opposite. So if we just draw a second graph here, so this is our graph here, it's just zoomed in on. This is the function 4 to the power of x. So I'm just going to write in that function here. So that's 4 to the power of x. This here in our green is our log x to base 4. So we can see that they are symmetrical or opposite to each other, and the line of symmetry is the line y equal to x or x equal to y. So always with our log functions, they are the inverse of our exponential functions along, they're symmetrical, I suppose, to our exponential functions, and the line of symmetry is the line x equal to y. Okay, so that's just something with our log functions, but this here is our answer to the previous one. And just the important thing always to remember is our x input values, we always use powers of the base.